Hey everybody, here is the first exercise that I want to go over with you. And this is just a little bit of review about relational databases and primary and foreign keys, which we've talked about a lot in class so far. So just to make sure that we're all on the same page. So hopefully by the end of this video, you'll have a strong understanding of what a relational database is, and you'll be able to set up primary and foreign keys in SQL. So a relational database, as we've discussed before in class, is basically a way to hold data over multiple tables, and these tables are linked to each other. Um, so some records are linked to other records in other tables. Um, all the data in the tables has a type, and all the values in a field are all of the same type. And what we see over here on the right side is an example of how this database might be structured, and it's generally referred to as an entity relationship diagram or an ER diagram. One of the things that this lets us do is it lets us query different types of data based upon these columns. So it's a very efficient way for us to go through this data and to filter through it in a quick fashion. Just a reminder on how SQL works. SQL languages, generally all the functions and keywords are capitalized, and all statements end in a semicolon. Um, all the names are generally case insensitive. All the commands are generally case insensitive if you want to do them that way, except for the names of variables. Those are case sensitive. But generally, the syntax is used that we always try to keep the functions capitalized and the variables either lowercase or um, just uppercase with the first letter. So as we've talked about in class, primary key for relational database is a column or field that uniquely identifies each record in the table. This is typically what's referred to as a auto-incrementing key. That way you never use the same key twice in any one table, so you never use the same number twice. So if it starts at 1 and the next number goes to 2, 3, 4, etc., etc. That way you always have a unique identifier associated with each record. If you delete a row from any table, that row will be lost, and so will that primary key forever. A foreign key is the way that we establish the relational relationship basically between tables. And here we see that foreign keys start to be located on other tables. So these primary keys migrate over to another table, and that's used as a foreign key. And this is the way that these tables are connected. And so basically each of these foreign keys will identify uniquely a row that occurs in another table. And the reason why we do this is that it ends up being a more efficient way of storing data without it reduces redundancy of information. So we're going to take a quick example on how to do this. And to do this, I want to show you how to make a database in MySQL. And we're going to take the below example of a relational database for some protein sequences. And in this database, there are 3 tables: ANOT, PROT, and SP. And in each one of these tables, there is a certain amount of information. There is a protein ID, a sequence, the sequence length. In the PROT table, there is the PROT ID as a foreign key, and the GI ID as a foreign key, a database, and a session number, a description, again, a GI identifying number, and a name in this SP, which stands for Swiss Prot table as well. You'll notice that these ints and text fields and even are somewhat familiar to you. You've probably seen them before. When you have them in parentheses like this, that means that it can't be an int that is any longer than 10 integers long. You'll also know that there's a varchar, that's a variable character field, and this is telling you that that character can't be any longer than 255 characters long. And here the varchar says you can't be any longer than 10 characters long. Additionally, there is what's called an enum field here. It's a little bit hard to read. And an enum field stands for enumerated field. And what you have in an enumerated field is you have one of these 5 options, or the only 5 possible options that could fit in that field. And the default for that field is GB. So these are actually 5 different databases you could choose from: GB, EMB, PDB, PIR, SP, and REF. So if we think about how we would build this database with these relationships and these connectivities, we see that whatever primary key exists on prot will actually become the foreign key over here on anod, and whatever primary key over here on SP will be a foreign key here on anod. So if we look at the commands that you would need to build this SQL database, we can go over here and we can see one, we have some commands that simply create database. Next, we tell computer to use that database. So here we're creating the protein database, we're telling the computer to use it, and then we're going to create the protein, the table for proteins. And you notice here that instead of just the protein ID, because if I actually look at this data, we'll see that the protein ID, there's actually an existing protein ID already there. So instead of trying to replace that ID with something new, that's actually information I want to retain. So I will make a new auto-incrementing column, which will actually serve as my primary key. And I'm going to call that ID. I'm also going to I will also generate this protein ID, which will match what's in the actual data. And I'm going to call this an integer as well, because this is going to be the index that exists within the actual data. I'll have a text field, an integer field for length. I'll then also create the table for Swiss Prot information. Call this the SP table. Again, this will have an SP ID as a tracking ID for this column. It'll then have a GI num, where this will be an integer associated, a specific accession number associated with the Swiss Prot data, and it's going to have a name associated with it, a variable character of 10 characters long. And finally, I'm going to create the annotation table, which will have information about the protein, and I'll have another auto-incrementing ID for this annotation table. I will have a protein ID and a GI right here, and these will actually end up being my foreign keys, these 2 columns. I have my enumerated field, as I discussed before, which gives me 5 different options, possible options for this field, and only those 5 options, and it's always by default GB. And a session number, which is tiny text, a description with this text, and then because I have 2 different foreign keys here, I have 2 separate statements that allow me to set up foreign keys. The first one creates the constraint fkprot and puts that constraint on the prot ID column. And what that constraint is it says that that prot ID column actually references the prot table ID column. So that's where that information will come from. That's the connection there. Then I put a second constraint on the table for the second foreign key. And here this is a foreign key to the SP table. Here I'm applying that constraint to the GI column here. And I'm saying that that column is actually referencing the SP table, specifically the SP underscore ID column. So if I go ahead and run my commands, you'll see that I am able to create all of the tables that I need to create. One thing I should mention is that in these cases, we have always made the foreign keys to actually be the primary keys of other tables. This is the most proper way to do database design. However, it is not a steadfast necessity that when you build databases, you do it in this fashion. I suggest it, as I think it's the most preferred and most professional way to do this. However, it is possible to, instead of making this ID field the foreign key in this table, I could simply make protein ID to be the foreign key in this table and connect them that way. In fact, I could even disregard and not have primary keys at all in my database if I wanted to. Again, this would not be the most responsible way to manage my data, but it certainly is a possible way that I could go about doing it if I wanted to. Not one I would suggest, but one that is sometimes done.